this lecture with Mr. Michael Popstan. I hope you all learn from me today, and I hope we can all learn from this presentation. But before I proceed, I wish everyone their safety, of course, their family's safety as well. I hope we all get through this crisis, and I wish everyone to do productive things, useful things during this quarantine period. Well, before we proceed with the ice and rain protection, we need to know what are we protecting the aircrafts from. So our aircrafts are flying as high as 45,000 feet above sea level, and with the height of the flight, different weather condition and temperatures, and even temperatures condition is experienced by an aircraft. Let me show you a graph of our height to temperature ratio on our atmosphere. Well, as what I've shown you, those figure have shown you that there are indeed different, or the temperature indeed goes low if you go higher. So the threshold is 0 degrees Celsius, and that is the freezing point of water. So basically, there will be ice during during a flight at this altitude. So as you can see, the higher we go, the lower the temperature gets, and this could cause icing on our aircrafts. Then, why do we need to fly that high? Those are the questions that comes up if we are discussing this. So the reason why we need to fly that high is to avoid bad weather, because bad and different ground obstacles such as buildings and high altitude mountains. Bad weather because bad weather is usually on the low altitude. It is just at least above 25,000 feet, so we need to fly above that. And high altitude mountains, of course, there is Mount Everest, the known or the known highest peak of a mountain. So thus we need to fly high above the weather, and having an ice protection is a lot cheaper than having to handle airplane crashes during extreme weather condition. If it crashes, or if it bumps into something, something high like a mountain or a building, or it gets, it crashes due to a bad weather. So aside from having ice protection, some aircrafts also have lightning protection, and a lot of aircrafts, uh, a lot of air aside from having ice protection, some aircrafts also have lightning protection, and a lot of aircrafts have withstand 8 to 12 lightning hits on average per year. Well, that is a fact. Actually, there are studies that aircrafts have taken lightning strikes more than 10 a year. So that was the average per year, and you can find that fact on a search engine like Google. Well, not all aircrafts as of today is complexly protected from lightning and ice. Some are just equipped with basic ice protection system, because these varies from the route that the aircraft takes. So if the aircraft is just bound to travel from tropical country to tropical country, of course it does not need a complex and advanced ice protection system and so on. And as shown on the figure earlier, the maximum flight of an airline aircraft ever recorded was 45,000, and 45,000 feet temperature goes down as low as 0 degrees Celsius, and this is the freezing point of water. Meaning to say, ice cannot be avoided at this flight condition. We can just protect the aircraft and de-ice the aircraft when it happens. So we proceed to the different kind of ice our aircrafts experience during flight at this condition. So we have, the first one is rime ice. It is spelled as RIME, rime ice. It has a rough milky white appearance, and this is how it looks like. I'll show you. So it basically looks like snow. Actually, it is rime is considered snow. And then the second one is glazed ice. The definition is it is a clear type of ice, usually has air pockets. I'll show you how it looks like. So that is a glazed ice. Glazed ice is, yeah, basically we buy this on our convenience stores. It actually worth 35 at 7-Eleven stores. So these are the big packs. Once you see it, the cube ice, it's called glazed ice. And then we have the mixed ice. This is basically the mixture of both. I'll show you how it looks like. So mixed ice are commonly seen if you go to an ice skating rink. Ice skating rink has a mixed ice. It has a rime and a glaze. So it is a mixture of both. Now, how do we know if there is an icing going on? So we know what kind of ice will do the damage to an aircraft. Now, how do we know if there is an ice forming? Of course, we have ice detectors. These ice detectors are called electronic ice detector. An electronic probe, so it is a probe externally that sends signal to the cockpit if an ice is forming, and it signals the pilot to perform a preventive measure or a de-icing measure. The probe is called optical transducer probe. It is placed logically, of course, to the critical parts of an aircraft during operations or flight. Once the probe detected an ice forming, it immediately turns on the ice protection system. Anti-icing is preventive measure, while de-icing is a cure. It is turned on after an ice is formed. Again, ice protection system for our aircrafts are classified into two groups. One is we have the anti-icers, and the first group is the anti-icers, and we have the thermal heat. This is through a heated air ducted spanwise, and this is commonly used in leading edges of wings of an aircraft. Leading edges in the front side of the wings. Leading edge is the front side of the wings. And having an ice in these parts of the wings can cause severe changes on our flight, meaning the lift or the ability of the aircraft to, fly up or stay upright will be reduced, and the drag or the force that pulls the aircraft backward will be greater than it should be. Second one is the prop heat or the propeller heat. This is almost the same with thermal heat, but a different location. Propeller is the source of the forward motion of an aircraft, and it basically makes the aircraft move. So without proper protection from icing, the propeller could be damaged and not perform its duty while on flight. It may cause a substantial damage not only to aircraft but also to human. Pitot heat, protection of the pitot tube of the aircraft. Pitot tube is located outside the aircraft, usually on the right hand side of the pilot, and the main purpose is to measure the pressure and the airspeed coherently so that pitot static instruments on the cockpit can work. Fuel vent heat. It is the protection of the fuel vent from icing that may occur under a certain flight condition. Fuel vent heat is necessary because when the fuel vent fails to do its job, fuel distribution may be disrupted, and we all know what happens when an aircraft flies without a fuel. Fuel vent controls the air coming in and outside the canister. We have the windshield heat. Well, windshield is of course the glass on the cockpit that is directly in front of the vision of the pilot, including the left and right oblique window. And these windows are the main visions of the pilot. And without protection, pilots will fail to fly an aircraft properly. Fluid surface de-icers. These are usually used to aileron and stabilizers of the aircraft as a protection. It is a methanol de-icing fluid that is employed to prevent icing on these parts. And the second group and these are the anti-icing system. These help the aircraft to avoid icing. Now, no matter how hard you try, ice can still be formed. And this is the second group, which is the icers. So we have the icing boots. The icing boot is a boots is a thick piece of inflatable rubber, but in the moving parts of the aircraft. So it is placed in the moving parts of the aircraft. When an ice is formed, a pneumatic system pumps air to the rubber to inflate it and remove the ice. So it is pretty brilliant. Engineers who have kudos to those engineers who have uh, invented it. It is the most common de-icers. So we have the whipping wing system. It is a chemical-based airborne ice protection system. It is discharged through small orifice when an ice is formed during flight operation. The chemical is glycol-based chemical. It provides anti-icing and de-icing protection for the aircraft. Heated wings is also thermal heat, but the difference is that this system is controllable by on and off, and is directly placed on the wings of the aircraft. Once an ice is formed, the pilots can control the span wire that produces heat and melt the formed ice. I'll be showing you pictures of the guidelines of what if an icing is occurring. And rain protection, almost all vehicles have the same rain protection. This is called rubber sealants. These are placed on the aircraft's assembled parts. So meaning to say, those parts that have been assembled, so it was put in the middle as a sealant. So it was not put on a one-piece metal or one-piece sheet metal. So there are a lot of places or components on the aircraft that needs protection from icing and rain. And as of today, airliners, engineers, and mechanics are continuously improving the safety of the people and the protection of the aircraft from any flight condition. I hope this presentation has been a help for everyone, and I hope we could all learn from this presentation. Thank you and have a great day.